There are three methods to estimate the due time. The first method is field measurements. It's the most accurate estimations, I would say, because you observe and you measure at the site. You just station at the busiest bus stop to do the measurements. And the second method is a very lazy method. Okay, you just use the default values. Like for example, 60 seconds for the downtown stops, 30 seconds for the major outlying stop, 15 seconds for the typical outlying stops. So you just use the default values, and of course this is not strongly encouraged. Method 3 is based on calculations which consists of a number of steps. Step 1, obtain hourly passenger volume estimate at the busiest stop. Okay, say for example along one bus routes there are 10 bus stops, so we only focus, okay, we only station at the busiest bus stop which has highest volume of passengers. So on step 2 is we have to adjust the hourly passengers volume. So we use these equations, peak hour factors. So peak hour factors, okay, we can use the default values like 0.7, and PH is what we want to estimate. But when we conduct or implement step 2, we only calculate, okay, the peak 15 minutes. So peak 15 minutes means that during this 15 minutes of time which has highest passenger volume. So but our ultimate aim is we want to know what is the value of PH means that the passenger volume during 1 hour, during peak hours. Step 3, determine the base passenger service time. Okay, we have boarding time. Okay, we have alighting time per passengers. So for boarding time, it depends on the fare collection methods. So you can see that, okay, if we implement prepayments, it will take shorter time, 2.5 seconds. But if we go by, like for example, exact change, then it will take longer time. So for alighting, it also depends on whether we allow passengers to alight through front door or rear door. And usually we allocate front door for boarding and rear door for alighting. So if you refer to rear door alighting, then the suggested time is only 2.1 seconds, but front door is 3.3 seconds because of we expect there is a conflict between alighting passengers and boarding passengers. Okay, and don't forget at the footnotes here we have to add 0.5 seconds per passengers, okay, when standee are present, and we have to subtract 0.5 seconds per passenger for boarding time and alighting time on low floor buses, at what I explained in the early slide. Okay, but if the bus consists of multiple doors, so means that what we discussed in the previous slide is only for bus with single doors. But if we have bus with multiple doors, 2, 3, 4, but usually it's 2 or sometimes it's 3, then we have different suggested time for boarding and alighting. Boarding, yeah, we have 2.5. Of course, if you only have one door, the boarding has take longer time, 2.5. But for alighting, it depends on front alighting or rear alighting. So if we allow them to alight through the rear door, then the time taken will be shortest. And step 4, we have to adjust the passenger service time for heavy to flow through a single door. So we say when 25 to 50% of the passengers through a single door is in the opposite direction of the main floor, means that there is a conflict between boarding and alighting. We have to increase both the boarding and alighting service time by 20%. Okay, so this is what we have to do in step 4. And step 5 is we have to perform the calculation of the due time. So due time TD stands for due time. We have PA, TA, PB, TB. And what is the difference between A and B? A stands for alighting, B stands for boarding. PA and PB is based on the calculations in step 2. So step 2 have to do 2 different calculations. One is for alighting passengers, the other one is for boarding passengers, and TA and TB is the passenger service time. Okay, we have gone through step 3 and step 3. Step 3, there are two tables. We use these two tables to determine what is the value of TA and TB. And TOC usually is constant because of is representing time taken for door to open and close.